Hey there, welcome back to ASP.NET Core 1.0 Intermediate Tutorials. My name is Jeff Fritz, and this is...
Hey, I'm Rowan Miller. I work as a program manager on the Entity Framework team here at Microsoft.
So we're going to continue going through some of our content about ASP.NET Core 1.0, and we're going to build on some of the things that we did a little bit earlier today. So we've done lists of products through a web API, and we've done some other things with data in memory. But what happens when we need that data to persist, right? A database or some other storage medium would be a great help, but we really want to get into saving to that database, and we want to use a tool like Entity Framework to help with that. So we saw a little bit with Entity Framework in our security module when we added Facebook access to the application. Let's take a little bit of a deeper look at Entity Framework in this module. So Rowan, what is Entity Framework?
So Entity Framework is an object relational mapper for .NET. So there's kind of two parts to that. So an object relational mapper is, I write objects. I'm writing C# or VB.NET or something. I'm writing classes, and I want to write code.
Okay.
I'm mapping to a relational database. And those two things are not the same thing. In one, I write C#, and the other one, I write SQL.
Right.
And so an object relational mapper just bridges that gap. It maps between the two. It means I can write queries in code, and the object relational mapper will take care of translating those into SQL.
Queries in C# or .NET code.
Exactly.
Okay.
Yeah, absolutely. And then for .NET, obviously just means that this Entity Framework is specific to .NET code. So primarily C# and VB.NET.
Gotcha. So then what's the difference between Entity Framework and now I hear Entity Framework Core?
Yeah, so we often refer to that as Entity Framework 6.x because we're currently on 6.1.3. So that's how we talk about that part of the stack. And then Entity Framework Core is this kind of newer, lighter weight thing. It fits very nicely in when we think about .NET Core and ASP.NET Core. It's lightweight, it's cross-platform, and it's kind of a reimagination of the framework that we want to take forward for the years to come. It is obviously the new thing at the moment too. So Entity Framework 6 is obviously the battle-tested, proven thing, but of course only runs on the full .NET framework, not these new places like UWP and cross-platform where .NET Core is taking us.
Cool. All right, well, why don't you show us a little bit about that?
Yeah, so let's swap over to my screen. I've got Visual Studio open here, and I've created the start of an ASP.NET Core application. And I've basically just done File New Project with the new project template.
Okay.
There's a couple of things I've changed, which I'll just walk you through quickly now. If we go and look in my project.json, aside from what is installed by default, you see I've added references to a couple of other packages here. So I've got Entity Framework Core.SQL Server here. So this would be the SQL Server provider for Entity Framework Core. We should mention that Entity Framework works great with SQL Server, but also works with a whole bunch of other databases.
Okay.
SQLite, MySQL, all the other main databases. And so we're installing the SQL Server provider because that's what I'm going to use for this particular demo.
Okay.
And then I've also installed the Entity Framework Core tools. So this allows me to use some command line tooling that is part of Entity Framework Core. And then you'll also notice I've got the SQL Server.design package here. And this just plugs in some extra tooling that's specific to SQL Server, which we'll see in action in a minute.
Okay, and these are updates to project.json. These are NuGet packages that were installed either by Visual Studio or by running that .NET restore command.
Yep, so I could have done right-click on References and Manage Packages. I could have handed it my project.json. I could have run commands in Package Manager console. Okay, cool. Just NuGet packages. Okay, now, when we demo EF, we often start with a new database. We write some code and then we generate a database from the model, which is how some people get to work. Sure. But lots of us have to write applications against an existing database. So I thought today we would actually start with an existing database. Cool. I've got SQL Server Object Explorer here in Visual Studio. You see I have a products database here. Very simple model that we should all be pretty familiar with now. It has a products and a categories table. They would have all the columns we'd expect in there and a relationship between them. Okay?
Sure.
Now we could hand edit, we could hand code a model here. We could write some code to connect to this database. That's going to be pretty time consuming to do. Yeah. For a trivial database like this with 2 tables, not too bad, but if I had something bigger with hundreds of tables in it, that would take a really long time.
And I always, when I try to do that, I always get a disconnect between my data types and some of the constraints on the data types when I'm building my .NET classes.
Yeah, and so you're going to spend a lot of time debugging trivial things that don't really help you write your application at all, right? So it'd be better to spend our time focusing on the finer aspects of our model. So we're going to use some tooling that we had. We saw those tools packages I had installed. So we're going to use a command called scaffold DB context. Okay. Because I'm scaffolding a DB context from a database. Now I need to pass this a connection string. Everyone knows how to write connection strings, so I'm just going to copy and paste it in there, right? You don't want to watch me type that. The three things I'm calling out in my connection string are, first up, the server. I'm connecting to my local DB instance.
Okay.
The database on that is called products. That's the one I just showed you.
Sure.
And we're using integrated authentication, Windows security, basically.
Okay.
And then the next thing I need to do is tell it what provider to use to connect, because the connection string doesn't tell me that this is a SQL Server database. Okay, so we're going to point it to the Microsoft.EntityFramework core.SQL Server provider. That is the name of the NuGet package, basically. That's an easy way to know what to type there.
Okay.
So the name of a provider is the same as the name of the NuGet package you installed to get the provider.
Okay.
So
And
we saw that name in my project, JSON.
And is that by convention, or is that truly the NuGet package name? Because if I grab somebody else's, some third-party provider's package, is it still that package name?
It's actually the assembly name, which almost always aligns with the NuGet package name.
Absolutely.
So yes, essentially it is by convention the NuGet package.
Okay.
Now, because I'm in an ASP.NET application, I would typically put my model classes in a folder called models. That's not always the case on all different types of platforms, but ASP.NET, that's typically what I do. So I'm just saying the output directory is models.
Okay.
I don't really want this stuff in the root of my project. So I'll run that. It should execute pretty quick, and then it will generate some code. Let's swap back to Solution Explorer. We'll see that we have the new models folder here. And I'm going to walk through the code that it generated for us. So there's two parts to an entity framework model. There's what we call the entity classes, and these are the classes that we're going to interact with at runtime. So we'd expect one of these for each of our tables. I'm going to want to query instances of my product class. And then we have a context, and a context represents a session with the database and allows us to connect to the database and save data and query data.
Okay.
So let's look at the entity classes first. We have category now. I don't really like the name categories. That doesn't make sense for an entity type, right? It should be singular category.
Yeah.
So I'm just going to rename it. And this is the kind of thing I want to spend time doing, like tidying up names. It's going to ask me if I want to rename the class as well. So yes, I do want to do that. You'll see I have a property here with a getter and a setter. Those generated based on the columns that were found in the database.
Okay.
Then we also have a relationship between the two of them. So a category has a collection of products. And this is where the object relational mapper really comes in, because I don't want to have to think about foreign key constraints and how to write SQL about querying related data. I just want to, if I have a category and I want to see the products, I just want to access the products collection.
Yeah.
So that's where the object relational mapper comes in. We'll go look at the product class as well. This one has a few more properties because it had a few extra columns in the database. And we'll see, pointing back the other way, we have another navigation property here.
Okay.
This one, a product belongs to a single category, so we just have one of those. You'll also see the foreign key property listed here as well, category ID.
Okay. So those navigation properties, those aren't actually anything in the database. It's just a way to traverse the foreign key relationships.
Exactly. You can think of it as a .NET code-based abstraction over the foreign key constraint in the database.
Cool.
All right. So let's rename this one too. Products doesn't make sense. Let's call it product. And we'll just say yes when it asks us if we want to rename the class as well. Okay, so those are the entity classes. Let's go look at the context, because that one's a little more interesting. Now, it's worth noting the tooling that we used can be used on all different types of applications, not just ASP.NET Core.
Okay.
So for that reason, it's just put the connection string here for us in code, but it's added a warning saying, like, this isn't the right place for your connection string to be. Depending on how you're building your application, this connection string should go in your user secrets or your environment variables or an app.config or somewhere else, depending on what kind of application you're writing. Now, in ASP.NET Core, things like that belong in the settings system. So we're actually going to put it in app settings JSON for the moment. There is nothing sensitive in here. It doesn't have usernames and passwords in it. If it did, I might want to look at user secrets or an environment variable instead.
Cool.
But this one, we're just relying on integrated authentications. So I have a connection string setting here. We'll just give it a name. Let's call it products. And I'll just paste in that connection string exactly as it generated it there. Okay. Now, the other thing that's not very in line with how we typically build ASP.NET Core applications, let me just get a bit more room on the screen here, is on configuring where I'm telling it what database to connect to and everything. If I was using Entity Framework in, say, a UWP application or WinForms or something like that, it would make sense to do this inline here. But in ASP.NET Core, all this stuff is usually done in startup.cs.
Yeah.
Okay, so let's make this a little bit more dependency injection ASP.NET Core friendly. So we're actually going to delete all of that. Instead of setting up the DB context options here, I'm going to add a constructor to the context that allows them to be passed in externally.
Makes
and
sense.
dependency injection is going to take care of taking the options that are set up in startup and passing them into my context. So we'll add that constructor. For folks that don't know that, I just used a little shortcut there. So CTOR tab.
That snippet
will give you a constructor.
Yeah,
That's standard in Visual Studio. And what I'm going to take in here is a DB context options. And we'll call it options. We can actually be a little bit more specific. We can say this is actually a DB context options for product context. I don't have to do that. This would just help if I had multiple different contexts in my application. And in fact, this can be true if I'm using ASP.NET Identity. It uses an EF context. And so I might want to say that specifically I want the options for the products context into this one, not the options for the identity context.
Sure, they could live in different databases.
Yep.
Yeah.
They could have other settings
strings
too, as we'll see. There's some other settings we could set up as well. And we don't have to do anything with those options other than pass them to the base constructor of DB context.
Cool.
And actually, that's an important point that I didn't really point out here. Our products context inherits from DB context, and this is basically what gives it all of its behavior.
Okay.
I often think DB context is effectively a session with the database. An instance of one of these represents a session with the database. Okay, so there's some other things happening in this class too. When EF runs, it's going to look at our classes and work out how they map to the database. And by default, it will say if I see a property named name, I'm going to assume that there's a column called name in the database too.
Okay.
But when it was reverse engineering our model, there's a few things that it wasn't going to pick up by convention. For example, we had a price that was of type decimal. So if we go and look at the price property on product, we'll see that it's of type decimal.
Okay.
By default, that maps to the SQL Server decimal type. But in my database, I've actually used the SQL Server money data type. So we see a little bit of config here saying the property price should actually have a column type of money.
Okay.
And then the other thing here, the name of my foreign key constraint in the database doesn't match what EF would calculate by convention.
Yeah.
So there's a little bit of config here to configure the name of the foreign key constraint as well.
Okay.
Okay. Now, we'll talk more about different options for doing this. One of them is to do them inline in this on model creating method. You can also do them using annotations on your classes as well. And a little bit later, we'll look at that because some people don't want to pollute their classes with attributes. Other people would prefer attributes over the complexity of writing code like this.
Yeah, using some of those attributes and putting them on the classes also helps with your validation then.
Exactly, yeah. And so what often people do, something like a maximum length. So if I had the name should have maximum 200 characters in it, that makes sense on the class because that's used by ASP.NET. It's used to do validation, like you said. Something like configuring the SQL Server column type, that's starting to mix concerns a little bit. So a lot of people would rather keep that out of the entity classes.
Sure, makes sense.
Choice. So you can pick what makes sense for you. The last thing we have here is DB set properties for each type in our model. And there's only two for us, right? Product and category. We'll see in a minute, these are the properties that we're going to interact with when we want to either change data in the database by saving, or when we want to write a query to fetch data from the database.
Okay.
Okay, now we have to go and work in Startup CS, and there's two things we want to do there. One, we want to do the configuration for our context in there. But we're also going to want to use our context in all of our controllers and everything, right?
Right.
So this means in the language of dependency injection, this would be known as a service.
Yep.
Context is a service that I want to be able to make use of in our controllers. So we need to set up the context as a service.
Now, can you talk a little bit about what a service is in dependency injection? We didn't use that term when we talked about dependency injection.
Okay. Did you use a different term earlier today, or we should just?
We talked about singletons.
Okay.
Right. So I think that's where you're going with this. We also talked about the scope.
Okay, so when I add, my context is typically used for a single operation. It's not thread safe.
Yep.
I shouldn't keep it around for a long time. I should use it to query some data, maybe make some changes, and then throw it away.
Right.
So when we talk about scopes, it's going to be a scoped scope, which means I get one of them per request. So if I have two requests come in from two different people, they're going to have two different instances of my context class and use them so that they're isolated away.
Cool.
A service is just a component or a class or something that we put in DI that we're going to want to make use of somewhere in our application.
Very good.
So other examples would be like the login manager for ASP.NET Identity. It's something that's in this bag of components that I might want to use, and then in my controller I can say, hey, give me the context. I don't have to worry about creating it or knowing what scope it is or anything. I just say, I need one of these.
Right.
Dependency injection will take care of giving me one.
Oh, yeah.
Okay.
It sets up all the connection for you.
Yep. So we need a connection string. So we're going to get that from configuration. Get connection string is just basically a sugar method that's going to go and look in that connection strings section that we had in our app settings.json, and we called it products. So it's just going to do a pattern match. It's going to look for connection strings, products in our config system.
Cool.
Okay. So now that we have the connection string, we're going to do services. And we're going to say we want to add a DB context. Again, this is just a sugar method for helping you get the context with the correct scope and getting the options set up correctly and everything. You don't have to use this. You could go ahead and just register your options and register your context as scoped and all those things. But this makes life easier, so we'll use it. We'll do the product context. And then I have the options, or the option to set up all that stuff. So all that stuff that was in onConfiguring, now I have exactly the same API here.
Okay.
So the method that we used before was use SQL Server, which is telling it go ahead and connect to a SQL Server database using the connection string that we just pulled out of config. Okay. There's other options on here too. So after I've done use SQL Server, I can do things like telling it, can I say batch size here? Yeah, like we can set up logging, or we can override the model cache, or we can externally pass in a model, things like that. So there's extra stuff I can do here, but the main thing that I would do from use SQL Server is tell it what database to connect to.
Sure.
Okay, so now we have our context in dependency injection container. We can use it in our controllers, and we're ready to go.
Okay.
Right. Now I've made a start on a controller, just so that we have to type a little bit less code, because I'm sure you've showed guys how to write controllers.
Oh, yeah.
Now, we want to make use of our context here, so we need to write a constructor. I'm going to use the CTOR, step it again. And all I need to do to get a hold of it is say that I want the product context here. And dependency injection will take care of passing in this for me. I want somewhere to stash it, so I'm going to say product context. Let's create a local field for it to live in, and I'll just stash it away so that we can use it in our actions. Making sense so far?
Absolutely.
All right. Index on the products controller. We probably want it just to display a list of all the products in the database, right?
Sure.
Okay, so let's write our first bit of actual data access code. So we're going to say products equals context. Now this is an instance of our DB context and is effectively a session with the database. Products is the DB set of product that we looked at before. And then I can say toList. Simplest query I can write. It's going to get all of the products out of the database and put them in a list.
Okay.
Now we should make this a little bit more complicated because ASP.NET Core works well with async, so we should actually swap and use toList async and await on it. Because it's an I/O operation, there's no need to tie up this .NET thread while I wait for this query to execute in the database, because .NET has no work to do while SQL Server processes the query. So this is going to tell it to use this thread for something else while we do it. And then all we want to do is return a view with the product on it, like so. Okay, now
Easy enough.
I've already written the views just because it would take a long time to write that, so let me show you what the index one looks like. This is very similar to what you would get scaffolded by default if you were scaffolding views. We're basically going through and doing a table, and it's going to display the name and the description and the price, and then some links to go and edit, delete, etc.
Right.
Make sense?
Yep.
Right,
Yep. We've seen this structure earlier.
Great. Let's run it. So when our application loads up, I'm going to go ahead and hit the products controller. Of course, it's going to hit our index action. And we'll see all the products from the database displayed on the screen here. So these are the ones I happen to have. You might notice there's a bit of a unicorn theme here. We can actually thank Scott Hanselman for that. Entity Framework 4.1 was dubbed by him as the Magic Unicorn Edition. Unicorn has kind of stuck around since then. You'll see it crop up in a number of places. Now, let's go back to our controller. What we wrote here was a query. It's actually using something called LINQ, which is Language Integrated Query.
Yep.
And this is a way of expressing queries not in Transact SQL, but in C#. And so I did the simplest thing possible here. I took the products, which is a DB set, which DB set implements iQueryable, which is kind of the root interface of LINQ.
Right.
And I did a toList on it. Okay. We can do extra things on here, like we can do sorting and grouping and basically anything I can think of that I want to do with queries. So let's look at a really simple one. So we can do an order by here and say order by name.
And the actual translation of this C# code, right? Translation, compilation of it to SQL code that SQL Server understands is all being done behind the scenes. It's not something we need to execute ahead of time.
Correct.
It just happens.
Yeah, so I'm going to run this again. I actually have SQL Profiler running in the background, so let's Let's run this, let's hit the action with the change we made, and then we'll look at the SQL that it generated
Okay.
in the background. So we'll go to products, we'll notice this time that all the products are alphabetically sorted here. And then if I swap to SQL Profiler, and we'll see this is the query that was executed in the database. Now, one thing to note here, this looks pretty similar to what I'd write by hand. We make a real effort in any framework to try and keep the queries as simple as possible. We've actually done a lot of work with the transition to EF Core to simplify the actual SQL that we generate.
The query syntax. Nice.
Now, in our case, it's a pretty easy translation because our property names all match our column names. Our type name almost matches our table name. So there's not a lot of mapping to be done here. But you will see it's pulling back all of the requested columns, and we have our order by here that we wrote in LINQ has been translated to an order by in SQL.
Sure, sure. Now, in previous versions, I remember seeing a lot of P0 and P1 aliases for the table names.
Yep.
So it's cool to see that it's simplified and a lot more concise. And like you said, something that I would write.
Yeah, exactly. And in all honesty, a lot of the times when you saw SQL that wasn't what you would write, it actually still performed the same. Like the SQL Server query optimizer is pretty smart. But even that being so, you want to be able to look at your SQL and understand what it's doing, right?
Yeah.
So if you're seeing, you would often see things selected into extent 0, 1 and then selected again from that, and it just makes it really hard to work out what's going on.
Trying to debug that, working with a database administrator to... Not fun to do.
Okay, so that's simple. We've looked at querying back a collection. Let's just do another one. So we can also use LINQ to query back a single object. So we have a details action here where I would drill into the details of one particular product. And what I get to do that is the ID that I'm after. So I'm going to say I want the product. Again, we're going to use the context and go into the products DB set. We'll write a where clause. So this is a new LINQ operator that we haven't used yet.
Right.
Product. And we want to say where the ID equals ID. And I don't want two lists because I would expect one of these to come back from the database, right?
Yeah.
So rather than two lists, let's do single. And we'll, again, return a view with prod. And when I'm calling this helper method, I'm not sure if you've covered this yet, but it's basically returning the view associated with this action.
Yep.
And it's passing this in as the model data, the
Yep.
product that I've returned. Now, again, we should be async friendly, so let's swap to single async. And we'll put an await in front of this. And then let's go ahead and run.
And because we're using a where method here, it's going to generate a where clause like I would see in regular SQL.
And because I only want one result, I wouldn't expect it to return all the data from the database, right?
Right.
So we'll go to the products tab again, and we'll just go to the details on one of these. And then we'll swap to SQL Profiler. And so let's look at a few different things here. So one thing that might not be immediately obvious is it's doing a select top 2, but I only asked for a single record. And the reasons it's doing that is single is very specific. It says there should be one record and only one record. Okay. So if you find 2, you need to throw. So that's the reason we select 2, just to make sure that there's only one.
Okay.
So 2 results come back, we'll throw. If you just want the first one, there's another LINQ operator called first, which will just give you the first, and it doesn't care if there's extras.
Okay.
So the reason we're selecting top 2 here is to make sure of that. And then you'll also notice the where clause. Another very important thing to note here, we obviously use parameterization. We don't just hack strings together because then you open yourself up to SQL injection attacks.
Yeah.
So we're passing in the ID we happen to be after was 5, and so we're passing that in as a parameter to the query.
Okay.
All right. We've looked at a little bit of LINQ, but you can't express everything in LINQ that you might want to do in T-SQL, right?
Yeah.
So a good example of that, I have our third action here, and this is the last query one we're going to do, where I want to search based on a term. Now, you know, I could products equals context.products, and then I could start putting together where clauses here, right? So we might say, you know, where the name contains, and I look for the search term, and then I probably want to hack together. There are database-specific technologies built to solve this problem. So full text search would be a good example of SQL Server.
Right.
Now, I actually have, if I go over to my database, you'll see that I have a table-valued function here. So we'll look in programmability and functions, table-valued functions, and you'll see I have a search products table-valued function in here. And this is making use of whatever database features it can to do the most efficient and most thorough text search for this term on products.
So I can select from the results of this function as though this function is a table.
Yes, and we're actually going to get to why that's important. So what I'm about to show would work whether this was a store procedure or just a function or a table valued function or whatever. Okay, so what we're going to do is actually, instead of querying using link, we're going to drop down to raw SQL.
Okay.
But we're not going to lose all the benefits of Entity Framework. So I'm not going to be responsible for creating instances of my types. I'm not going to be responsible for knowing which column maps to which property. EF is still going to do all that for me. It's just going to let me replace my link query with a raw SQL query.
Oh, fantastic.
Okay, so let's look at that. So let's get rid of this where clause, and we're going to use a method that is only in EF Core, it's not in Entity Framework 6, from SQL, which takes in a string. And as you said, with a table valued function, I do a select star from, and the name of it was search products. And then it took a single parameter, which was the search term. Now, this looks like I'm about to do a string.format, because this would be string.format syntax, which obviously would be a horrible idea, because that would open us up to a SQL injection attack. Because if someone searches for, you know, semicolon, delete from, you know, horrible.
Those magic characters that.
So from SQL, after it's taken the string, can take some extra objects after that. So I'm going to pass in term, and it will take care of wrapping those up into SQL parameters and passing them back into the string where these placeholders are. So this doesn't mean it's going to take this and directly translate the string into here. It means it's going to create a parameter that wraps this, and then it's going to put the name of that parameter where this placeholder is. So we are SQL injection protected by doing this.
Fantastic.
So we'll do toList async. Of course, I need to await that. And same thing we've been doing so far. I'm just going to quickly show that this works, and what we would expect is for Entity Framework to not do anything fancy here. I told it what SQL to run, so I would expect it to go and execute exactly that SQL for me.
Yeah, pass it right over.
Yep. So let's search for shirt, because I know I have a few shirts in the database. Okay, the shirts come back, and if we go look in SQL Profiler, we'll see that the last query to execute was exactly that piece of SQL that I passed in, and we'll see there's a parameter there, and we'll see that my term shirt is being passed in as a parameter value.
Cool.
Okay. Now, when I drop down to SQL, in the past I've been restricted to writing the rest of my query in SQL. So say I wanted this data ordered. I would have to go over here, and I would have to keep writing in SQL. I'd have to say order by name and stuff. And then I'm losing all the benefit of the ability of EF to translate things into links. So now, in EF Core, I can actually do an order by product.name. And let's run this again. I'll just take a second to compile and restart. So interestingly, what I've done here is I started with SQL, but then I started composing on top of it using link.
Right. So you're able to extend that base SQL statement that you wrote that was optimized for your needs and might have been trickier to write, and you've turned it into and extended it into something pretty useful.
So now we're sorted alphabetically here, and if we look in SQL Profiler, we'll see it took that statement that I wrote and wrapped it in a select because it's a table valued function. It can do that, and it's put my order by at the end here, which is quite nice.
Yeah.
Now, you can't do this with every piece of raw SQL. For example, you can't do it when you select from a store procedure because store procedures don't support this composition type thing we're doing here.
Okay.
But because it was a table valued function, we can compose on top of it using link. An easy way to remember that, basically, if the fragment that you pass in starts with select, then it's composable in SQL Server, and we can compose on top of it using link.
Yeah, I suppose if you were in a stored procedure returning more than one table, you'd run into problems here.
Yeah, absolutely. So this is restricted to things that work with select.
Okay.
Okay, so this was kind of an introduction to
cool.
query. Obviously, we've covered we've skimmed the surface of what's possible with link. You can write link queries that take up pages in code. They can get very complicated. But we've showed you basically how link works and how we have handles.
Yeah, we can do our simple reads from the database and some more advanced query if we need to using the from SQL.
Absolutely.
Cool.
Okay, so the next thing I think we can get data out of the database. Let's look at changing the data that's in the database. So I've got some code commented out here. I'm just going to uncomment it. And these are actions that we're going to use to create, edit, and delete instances from the database. Now, I'm not going to go super detailed and run it after we implement each one. My idea here is to introduce you to the API surface and how you use it with Entity Framework. And then I'll point you to the EF docs at the end, and this gives a whole bunch of detail on exactly how these things work and everything. So there's always two parts to these things. There's when we want to create something, there's the first action which just kind of populates the create screen for you.
Yeah.
And so in our case, a product is related to a category. And so one of the things it's doing is creating a select list and giving that data to the form to allow you to have a drop down with a category in it.
Okay.
Okay. The interesting one is when that create comes back. And so it's going to say, here's an instance of the product. We'll see that over here. Here's an instance of the product, and I want you to save this to the database. Now, I'm going to keep the code in here really simple. Obviously, as you write real applications, there's going to be some validation you want to do.
Yeah.
Yep.
We were looking at working with model state in our previous module that we were talking about Web API.
Yep.
So
for example, just based on this domain that we're in at the moment, it probably doesn't make sense for products to have negative prices. But at the moment, it's just the CLR type decimal. So that, of course, negative prices could be entered in the form. We would need to do some form of validation.
Yeah,
but that's going to be very domain specific. So we're just going to stick with the basics of how do I save this data.
Okay.
So I would say context.products, products being the DB set, which we have used to query. But instead of querying this time, we're going to say add. And we're going to pass in that instance of the product, which MVC has handed back to us to save.
Okay.
Now, one thing of note here is that context doesn't, when we do this, it doesn't immediately go and put it in the database. A DB context is often referred to as a unit of work. It kind of saves things up and it gets ready, and then you tell it when to persist those changes to the database. In basic MVC actions, it's typically only one thing you're doing. You're creating one thing or you're deleting one thing. But as you write a more advanced application, you might be inserting 3 or 4 entities as part of creating a new product.
Right.
Maybe you need to create a product details with a photo on it and some audit entry records and things like that as well.
And you need those to all enter the database at the same time or very close together.
Yeah, and so what EF would do is it would actually batch all those up into a single command and send that to the database. So if you insert 4 objects, we'd insert 4 objects as part of the same command. And more importantly, we'd do it transactionally. So that whole save changes is always wrapped in a transaction. So you don't have to do anything with transactions unless you're doing something complicated. EF, when you call save changes, which is what we're going to call now, and that's async, so we'll await it. Think of this as flush all changes to the database, and it does it atomically. So if it inserts 2 things and then 1 fails, the whole transaction gets rolled back. In our case, there's only one thing we're inserting anyway. So
yeah, it shouldn't be too risky.
Okay, so that's how we add a product. Let's scroll down a little bit further. So we're going to do edit next. Again, this first action is the one that populates the edit screen. So it gets the data up in the form for the user to edit. And so this query looks very familiar. We're doing single async, and we're fetching back the single object with the ID. One thing I would just call out here, there's actually an overload of single async which allows you to pass in effectively a where clause. So whereas we did our products.where m.id equals ID, single async without anything in it, you can actually collapse those down into one call, which is why this one looks a little different.
Okay.
Okay. The one that we're particularly interested in is the edit when it comes back. And so in this case, it's given us the ID and it's given us the actual product that needs to be saved back to the database. Now, there are lots of different ways to implement the body of an edit method. I'm going to do the simplest one, and then I'll talk about the shortcomings of that in a second. So we would go to the context, we would say products, and we would say update product. And then, of course, we're going to flush that out to the database, so we would await on context.savechanges async. Like so. Update is very simple in that it just literally sends an update statement and sets every property to be the incoming values.
Now, how does it know which product to update?
Because of the ID based on the product. So
Gotcha.
the product coming back has an ID on it.
Okay.
So it will send an update, set all of the columns to the values out of the properties where the ID is equal to the ID of the product. Now, there are some cases where you might not want to do that. One, if you have auditing or something in the database, you're updating a lot of columns, but you might just be setting them to the same value. Okay, so you can see that some people, if all the user changes on the form is the name, you might want a simpler SQL statement that just updates the name column.
Okay.
So in that case, the way you would do that is you would query back for the instance of the object from the database, and then you would
set the value.
Copy the values over the top. Another place you might not want to do it is if you don't have all of the properties of the product on the form, in which case you can't just update them all because some of them are going to be null and you don't want to set nulls in the database.
Okay.
And then also if I'm doing concurrency detection where I'm saying if another user's edited the record, don't just stomp your changes over the top, check with the user to make sure that that's actually what they want to do.
Yeah.
So if I'm changing a person's name but someone else has changed the social security number, you should probably double check that that's the right edit before saving it.
Oh, yeah.
Yeah. So this is a very naive approach. It's simple. It gets you off the ground. You can write much more complicated code to achieve more complicated outcomes. All right, delete. Again, it's two actions that work together. So the first one just gets the product from the database and displays it and says, are you sure that this is the one you want to delete? And then in our delete confirm, this is where it's saying, yes, I want to go ahead and delete this product with this ID. So we don't get the whole product this time, we just get the ID. So actually, again, there's various ways to implement this. The easiest one is to go ahead and fetch that product from the database. And then once we have it, we're going to say products.remove that product that we just fetched based on the ID. And then as we're familiar now, we would await on a call to save changes async.
Makes sense.
Make sense?
Yeah.
All right. Let's just test out one of these actions to make sure that we did everything right.
It's interesting that the create and the edit, right? They're synchronously operating locally, but it's when they flush, when they persist those changes, that's when it goes async.
Yeah, so when they're doing things like adding it to the context, that is completely in memory.
Mm-hmm.
So the .NET thread has work to do the whole time that that is executing. The place where the .NET thread doesn't have anything to do is when we flush them to the database. It goes through SQL client, and then it drops out of .NET and goes down and across the network to the server and back again. And there's nothing for .NET to do in that period. And so that thread can go service another request while that happens.
Okay.
Let's just delete one of these products. So let's delete the unicorn pencil. It's not been a very good seller. So we got the query from the database, the confirmation screen. We'll delete it. And then if we go look at SQL Profiler, we should see a delete statement issued to the database.
Cool.
And we see it's parameterized again on the ID property is effectively what we're deleting based on.
Nice.
Okay. That all make sense?
Oh yeah, and then it even selects row count at the end just to make sure that it got that one row changed.
Yeah, absolutely. We always check that when we issue anything to the database, a create, an insert, or a delete, we always make sure that the right amount of data got updated in the database. If it didn't, we roll the transaction back and we let the user know with an exception or the developer know with an exception that we would call that a concurrency violation. So you tried to delete a row, but it didn't change anything, which probably isn't what you expected. So here's an exception with all the details of what you were trying to do. We'll roll the transaction back and leave the database alone, and you can write code to decide what to do when that happens.
Cool.
Okay.
All right.
Any questions on this before we move on? So the next thing that I wanted to show quickly was we looked at creating a model from an existing database.
Right.
Now, what if I don't want to work? What if I want to start in code and then have a database created for me? And then what if I want to change that code and bring the database up to date with those changes in code?
Yeah, right. This is what we saw with migration when we did things with identity.
Yeah, absolutely.
In an earlier module.
Okay. So let's just close all our windows down here and get things a little bit more squared away. So in that situation, we would have a model written in code that we would write by hand, and we wouldn't have a database. So we're actually going to stay working in the same application. I'm just going to literally delete this products database from my local DB instance. We'll take a minute. I think I had an open connection there when I was looking at data from it. And we would, at this point, we would have written all these things by hand. So I would write my entity classes to represent the domain model that I want for my application. I would have written a context that would have had DB sets for all the types of my model.
Sure.
Because I'm in ASP.NET Core, I would have taken my options externally, so the same as all the code that was generated for us. And then I could have done optional config here. Now, interestingly, in this case, I don't really care what EF picks as the name for this constraint, so I'm actually even just going to delete this just to keep things simpler. Don't have to, but I don't mind what that's called, so it's less code for me to deal with. So this is something that I might have written by hand.
Yeah.
Okay. Now I want a database from it.
Okay.
To do that, we use something called migrations. So add migration is the command. We'll call this one initial schema. The name is not important. I can call this whatever I want. Call it my first migration. All it's going to do is it's going to look at what has changed in the model since the last migration was generated. Now, there aren't any previous migrations.
Right.
So everything changed in the model. So our first migration that gets scaffolded, and we'll talk about exactly what a migration is in a minute, is some statements that are telling it to go and do these things in the database. Now, this is very database specific at this point. We're not talking about entity classes and properties. We're talking about tables and columns, and we're talking about value generation strategies being the identity column in SQL.
Yeah, so, right. And this is essentially the DDL, right? That data definition language that we would use directly against the database, but it's being wrapped up into something that's .NET friendly.
Exactly. Yeah. Now, migrations, the brief description of migration, it's a well-ordered set of steps to take a database from any version up to the current version.
Okay.
So my database doesn't exist at the moment.
Yeah.
And I have one migration. So there's one step to get from no database to
A database.
current model, which would be to create the database and run the code that's in here to do all this stuff, creating the two tables for me. So let's do that. The way I do that is with update database. And given that you have, I think you looked briefly at migrations in Identity, I'm going to take a little more time to talk about how migrations works, because that's an important thing to have in your mind.
Please, yes. We saw the database error page, database exception page, where it gave us that cool button to click and apply the migrations. But we didn't go through and do this on the command line. We kind of got the help through the user interface, through the web browser. And I don't want my QA folks or even my users in production to have to click that button in order to update my database.
In fact, they shouldn't. That piece of middleware should only be used locally. It's more designed as an education thing when I'm developing. I think once people get used to that error page, they should probably proactively do that stuff in Visual Studio before they run.
Sure. But I could see also in a team scenario where you're working on one set of code, I'm working on another set of code. When we both get up to date the next day, oh, there's some changes that you made.
Exactly.
I can push that button without running through anything, and my stuff's up to date.
Yeah, absolutely. Okay, so the way this worked, it looked at the migrations in my compiled application. So the first thing it did was compile the application. It then looked at my assembly and said, oh, there's one migration in there. This one called, let's go back over. Saw the migrations folder here. We'll talk about the model snapshot in a second. Let me just pull out and give us a little more room here. So we'll talk about snapshot in a minute. The initial schema, it saw this one migration and said, this hasn't been applied to the database. In fact, there isn't even a database. So it created the database and applied this migration.
So when you added the migration there in the PowerShell window, in the package manager console, it created a class. It didn't write SQL statements. It created another class that defined, here's what needs to be applied.
Yep. So in the same way that writing entity framework link queries and things like that is an abstraction over writing select statements and insert, update, delete statements, a migration is an abstraction over writing create table and create foreign key.
Those DDL statements, yeah. Okay.
So it's a bridge. It's kind of partway between your model and the database. It's written in terms of database objects, but it's still in C# and a little bit abstracted.
Right. Right. Okay.
The other important point too is because it's not SQL, different providers can translate it differently. So I could run the same migration on SQL Server and SQLite, and they might generate slightly different DDL. Because SQLite doesn't have identity columns in it.
Right.
Yep. Okay, so we'll refresh this. We now have the products database back. It looks a little different this time though. It has our products and categories tables. That's what we'd expect, but it has this new table, EF migrations history. So let's open that. This is how EF tells what's been applied to the database. So remember I said it's a well-ordered set of steps. It needs to know which steps it needs to go through. And so the way it knows which ones have already been taken on the database is by looking in this table. So we've now recorded
a copy.
This migration has been applied.
Nice.
To really get the gist of how migrations work, we need to look at making a change. So I've been coding away on my app for a while, and I realized that I really want a rating property on my product. Okay.
Social interactions.
Yes, absolutely. Okay. So at this point, my model and my database are out of sync. There's no rating column in the database. So I'm going to use a migration.
So I'm going to ask the question, so what if they're out of sync, right? That's where we start to see that white screen error, right? Okay.
So if I tried to select products, it would try to select the rating for the product, and it would generate invalid SQL because it would try and select from the rating column, and there wouldn't be one. So I would see a SQL exception. And to your point, if you have the database error page enabled, it would be smart and tell you, hey, this is probably because your model and your database are out of sync. You should scaffold a new migration.
Okay. It never generates a select star because it is generating the select statement with each of the properties listed. Because you added the property on C# side, it doesn't exist SQL Server side. So it has that disconnect.
Helps us know ahead of time that all those columns need to be present in the statement.
So do you have that same problem if you add a field to SQL Server and you don't have it in C#?
It depends what you're trying to do. So in terms of select, no, because to your point, we don't do a select star. We only select the columns that we care about. And it's perfectly valid to have columns in your database that you don't care about in your application.
Okay.
So maybe you have a particular column that the DBA keeps up to date, or a column that's maintained by a completely separate application that isn't related to the one you're working on.
Not in my context.
Yep. So for a select, it's not going to matter because we'll just skip that column from the statement.
Yep.
For an insert, it's not going to matter as long as the database is set up to allow either a null or it has a default value on that column. So it's not going to matter if we miss it from an insert statement.
Gotcha. That makes sense. Okay.
Yep. So that is perfectly valid.
Cool.
Again, I can call this whatever I want. I'm going to call it product ratings because that will help me remember what this guy did. Now, what it's doing at the moment is working out what changed since I generated the last migration. This is where that snapshot file that I pointed to comes into play. So this snapshot over here in Solution Explorer is a snapshot of what the model looked like when the last migration was generated. And so the way EF works out what's changed is it runs your code and gets your current model. It runs this product snapshot code to get the previous model, and then it does a diff of the two of them. And in this case, it's going to work out that there was a ratings property added, which should result in a ratings column being added in the database. Now,
so at some point that snapshot will be updated.
Yeah, this snapshot now has the ratings property in it.
Okay.
So if we go and look through it now, if we found the products one, we would see there's a property.
Oh, there's the rating.
Yep.
Okay.
Now this is very weakly typed because I might later on in the future, I might delete that ratings property. And so this code doesn't reference your model at all. It's just kind of weakly-ish typed. So it doesn't matter what happens with your model over time. Now, migrations are scaffolded code. They're not, don't think of them as designer code.
No.
These are not, you can touch these things. We don't always get it right. This is our estimate of what needs to happen in the database. Now, for simple operations like adding a column, it's going to be right. But I might want to tweak it, like default value for the existing data in the database. Rating of 0 doesn't necessarily make sense for all the existing products. I might say all the existing products should get a default value of 3. So I can edit this code. I might want to reorder operations. I might know, or it might generate a drop and create a new column, but I actually know that that data should be copied across before we drop, so I can write extra stuff in here. Let's go to Package Manager console. We'll run the update
database again.
Database command. Now what it's doing, it's looking at all of the migrations in my solution or in my compiled application. There's 2 of them now. It's looking in the migration history table in the database. It only has 1 record as applied, so it now knows that it needs to apply my product ratings migration.
It did the diff between the two to see here's the ones that I need to apply, and then there's an order that they need to be applied?
Yep, absolutely. So this is a date and timestamp at the start of them, and this defines the order that they're applied in. Okay, now in both of my cases, there's only been 1 pending migration, but of course I might be a developer that pulls this application from source control, and I run update database, and I don't have a database yet, in which case it will create the database, and it will apply our first migration, then our second migration, and now I'm up to date.
Cool.
Okay, and just to show that it worked, if we go look in the migration history table, we'll view the data on that.
2 records.
2 records there, that's what we would expect. And if I look at the products table, I will now see the new rating.
The rating.
Cool. Introduced there. Okay, any questions on how migrations works? Or?
No, you've answered them very well as we've been going along.
Okay, great. The last thing I wanted to leave you with, obviously this has been a skim across the surface of what EF can do.
Oh, sure.
And, so I just wanted to close by linking to our docs. Let me just close down this and go back into Edge. Now the site I'm going to is docs.efproject.net. This will link to our documentation for Entity Framework Core.
Okay.
And you'll see that things are organized. We have getting started for each of the different types of platforms. So if we're looking at getting started for ASP.NET Core, then this would give a walkthrough very similar to what we just did now.
Right, okay.
And then the sections are really organized into the same way that we had our module organized today. So there's a section on creating a model, and it talks about how you would do things. So one of the things that we looked at, we were looking at renaming relationships we had, or specifying data types. So we had data types here. That was the example we did. We mapped to the money data type. So you'll see here as an example of mapping to varchar 200.
Sure.
Okay, so that's how you would find all of that stuff for creating a model. And then there's querying data and saving data, which were the 2 topics in which, and that covers the vast majority of operations that you use in the Entity Framework.
Cool.
All right, so I think that's a good introduction. Obviously, there's a lot more, but folks can go off and learn that, browse through our docs, and yeah, get up and running with data access.
That's a great intro, and that gets you 80 to 90% there for most of the stuff that you need. So thanks so much for joining us. That's what we're going to talk about. That's all we've got for the Entity Framework module here today. Come on back in a little bit. We're going to talk about publishing our applications in the next module of the ASP.NET Core 1.0 Virtual Academy.